to temperature sensor. So in particular, there are two components you need to familiar lah. Okay, let me explain the first one first, called the RTD. Okay, resistant temperature detector. Alright, so okay, now basically the sensor, right? This is a sensor. Alright, so if you can see on my board here, okay, so the RTD is basically in ohms. Alright, so it is on this axis you got ohms versus this part here is degrees Celsius. Okay, now because it is a linear sensor, you know, I believe you all know what is linear. Right? Linear means that the output of this RTD, right, actually is measured in ohms, resistance, right? But this resistance corresponds to a particular temperature, okay, in degrees C. So this is what we want. So, but you must remember that what we measure from the sensor is in resistance, right? But we need to somehow convert that resistance into a relevant temperature in degrees Celsius. Okay, so to cut the story short is that when you were doing this experiment, alright, I believe you have heated up the temperature of the little enclosure, right, to about, what's the temperature again? Was it 50? Was it 50 degrees? You all heated up the enclosure to 50, right? So you can see that we drew a line here. Okay, now you must understand that, okay, what we did, right, because we started at the room temperature, right? Remember, we are in the room temperature. Now what is we make a guess what is the room temperature? Maybe 25 degrees, right? In this aircon room condition. Okay, now what is this? Because this is a linear sensor, you know that your equation is y equals to mx plus c, right? I hope you remember. That's your basics. But in this RTD, right, there is a relationship also. This is called RT, right? There's this thing called R0 plus this. I don't know, I hope you all can remember. Okay, so now we are talking about RT versus temperature T. So this is like your y-axis, this is your x-axis, okay? Now, so this relationship is given to us, okay, because it is a linear equation. Now, there's this thing called R0, 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 okay? So what is this R0? So if you remember, what is your equation? You all remember, you all learn, right? There is this thing called y equals to mx plus c, right? What is the c? What is c? Can somebody tell me? You all know what c? C means what? If this is y, this is x. What is C? C means what? It's the intercept. Am I right? Yes? So what is M?
Slope.
M is the slope, right? Very good. Okay? M refers to the slope, equals to the M slope. Okay? So similarly, likewise over here, we have RT versus T. Right? So basically this equation is also similar because it's a linear equation as I mentioned to you. Okay, now what happened is that this expression is given to you, so it's RT equals to R0 plus R0 alpha T. And now this alpha is a coefficient, okay, coefficient that is specific to that sensor. So it's like a coefficient, if you like. Okay, so it's a specific one that is relevant to this particular sensor you are using. So it's a constant, in other words. Okay, it's a constant, right? It's alpha. Is a coefficient, which I'll explain to you. Now, so basically when you did the experiment, right, you guys, when you did the experiment, now remember, because this axis, okay, what is this point here? Okay, if you ask yourself a question, the equation, right, the equation by right here, if you remember, y versus x, this coordinate here is 0, 0, am I right? Okay. Now, if this line, this thing that you plot, I don't know whether you have done up to this point already. You are supposed to follow the instruction, right? So when you started off the experiment, you started off like maybe in room temperature 27 degrees Celsius or 25. Alright. So you were supposed to heat up to 50 degrees, right? This is 50, yeah. This part is 50 degrees. You started the experiment at somewhere maybe 27 degrees, let's say, yeah. Okay. Okay, so now you started heating up this. You only get a segment of this program. I don't know whether you realize. After you click, after you finish the experiment, you only get from 27 to about 50 degrees. Right? But don't forget that when we talk about the equation, the C is the y-intercept at 0 degrees here. This point here is at 0 degrees Celsius. Agree? Now, however, you realize that hey, there's no way in this lab that we can go 0 degrees Celsius. Am I right? In this room condition, how to go 0 degrees? Okay, agree? You cannot go 0. How to go into 0 degrees Celsius, right? So what we do, mathematically, we use this function called extrapolate. Okay? So if you notice that you have one button you all follow, right? I think just now I saw one very nice straight line. You follow the instruction, you click extrapolate, then you run again. So what it does is that extrapolate is a fancy word. It means to extend the line. Okay, extrapolate means is to extend the line in simple layman term. Extend the line. Okay, so you already got this part here. Is it easy to extend this line all the way until you hit 0? Possible, right? You see what I mean? So you extrapolated this part from 27 all the way. He draw for you the program will continue until you hit 0. This is what we want, right? Because I told you, because C in mathematics you all learn C means the y-intercept, right? Y-intercept, this part here means is at when the x is 0, right? Okay. So over here, same thing. We extrapolate at 0 degree because we cannot get 0 degrees Celsius in the lab environment. So we mathematically do this extrapolate to extend this line, and you all should be able to get the y-intercept. Okay, later I come and take a look. So you should see that you can move the cursor later, and you will see that in your experiment there's this thing called like a crosshair cursor. This cursor can move, you can slide along this line. So when you slide here, you can actually observe actually your y-intercept is about this value. So, but I must admit that every set is different. So your extrapolated the y-intercept value, the R0 may vary from one board to the next board. But overall, it's about, roughly speaking, about 98 ohms. Roughly speaking. So, but it will vary. Some get 97, some get 99. It's okay. Okay, but I want you all to understand the concept. So you get this 98, right? Let's say, this is the y-intercept, which is the R0. Now, if you got R0, can you find from the equation of a straight, can you find the slope? Can, right? If I give you two coordinates, you can find the slope, right? You agree now? Any 2 points. Because you will apply the formula, right? y2 minus y1 over x2 minus x1, right? Remember that formula? You get the gradient. So you get the gradient means you find the m. If you can find the m, you already found the R0. Can you find what is alpha, which is what is being shown here? Right, you get the gradient first. You can solve the gradient later. I'll go around and help you all. Write the gradient first. Get the gradient ready. Right, you know what is your R0. Okay, because you can observe from the graph the intercepting point. Then you can find what is alpha. Alpha is the temperature coefficient. Okay, for the sensor. Okay.